I wanted to do a quick video reminding you how to find the domain of a function. So there's two things that you cannot do, and one of them is that you cannot divide by 0. That's my Chuck Norris joke. Okay, so I'm going to take this for a second. I'm in my classroom, and when you look on the wall, sorry about this video, there's that lovely Chuck Norris can divide by 0. It's a joke. It's hilarious. I think it's so funny. I'm easily amused. Chuck Norris can divide by 0, you can't. Okay, it's a joke, whatever. But you can't divide by 0 because that's impossible to do. The other thing that you can't do is that if you take the square root of a negative, you have left the real world. Okay, and when we're graphing, we have real numbers on the x-axis, and we have real numbers on the y-axis. So if we take the square root of a negative, we're no longer real. So let me show you. So those are the two things we can't do. So if I have something like f of x is equal to x plus 1 over x squared minus 4x, let's see, minus 5. I don't know. I'm making something up. So when I see this problem, I don't want my denominator to be 0. Notice I don't have any square roots. So I'm just going to say, okay, well, what did I have? I can factor this to be x minus 5 times x plus 1. If you're struggling with factoring, I made a video on factoring a couple days ago, so go look for that. Right, is this correct? Negative 5x and a positive x gives me negative 4x, and that's okay. Notice this is this would cancel, which we'll talk about later. So this graph right here is going to look like this one, except it's going to have, this will have a hole. If that weirds you out and you don't know what I'm talking about, hang tight, I promise. We're gonna study this better this year. But even it'll have a hole right here. Even if you take it out here, it's still not going to have this value in its domain. So sorry, I didn't intend to make that a hole, but there we go. So what happens here is that x cannot equal a positive 5, because if I plug in a positive 5, I get 0 in my denominator. And x cannot equal a negative 1, because if I plug in negative 1 here, I get 0 in my denominator. So one way that this is helpful to look at is to say, well, here's negative 1, here's 5 on my number line. I can allow my x value to be everything else. I just can't let it be those. So drawing the number line helps me to then say, okay, so it's negative infinity to negative 1. It doesn't include negative 1. Then I pick it up again. That means union, negative 1 to 5, union 5 to infinity. And do you see, this is interval notation. I could use set notation, which set notation is similar to this. It's just saying it's the set x such that x is not those things. Okay, so that was set notation, that's interval notation. In these type of problems, typically interval notation is a little bit easier, not always. Set notation will definitely be helpful when we get into some of our trig, so I want you familiar with it. Let's look at another one. Let's say I have g of x is equal to, x plus 7 over x times the square root of x minus 4. I don't know. Okay, so what's happening here is I have the potential of, I have a square root. So I know that x minus 4 has to be, we said we can't take the square root of a negative. But we also can't divide by 0. So notice my radical is in the bottom. So not only, normally we would say this, it has to be greater than or equal to 0. But in our particular scenario, because it's in the denominator, we're going to actually just go ahead and say x minus 4 has to be greater than 0, because if it were equal to 0, then I'd be dividing by 0. And I'm not Chuck Norris. So here I have x is greater than or equal to a positive 4. Oh, this is clever. Okay, and I didn't intend to be clever, but here we go. And also we know from here that x cannot equal 0. So what I'm going to do is I'm going to put this on a number line, and I'm going to say, well, here's 0. I can't be equal to 0. And here's 4, and I have to be greater than 4. So in this particular case, this one has no impact on that one right there. We just have to be bigger than 4 anyway. So my answer would be from positive 4 to infinity. Okay, I'm going to use a different color. If this had been a positive right here, okay, then this is a new scenario. I still know x cannot equal 0, and now x has to be greater than a negative 4. If I change that little problem right there. So when I put this on my number line, here's negative 4, here is 0, and we can't be equal to those. We have to be greater than -4, so it's looking something like this. So here you would say -4 to 0, pick it up again from 0 to infinity. Let me do one more. How about another clean sheet of paper? What if I say something like f of x is equal to the square root of 2x plus 3 divided by x minus 1. I don't know. I'm just making something up. On this one, we have to consider both things. Well, here, since this is not in the denominator, I just need the 2x plus 3 to be greater than or equal to 0. Okay, so it doesn't matter. The square roots, typically, we just say greater than or equal to 0. The only time we don't put that equal sign, remember back here, it was in the denominator. That's when we didn't want the equal sign. 2x is greater than or equal to -3. X is greater than or equal to -3/2. And I also know from here that x cannot equal a +1. So here's where my number line is very helpful. -3/2, and then 1 is bigger than that. I can be equal to this, so I'm going to do a closed circle, an open circle here. I want all of that. So it's -3/2 to +1. Pick it up again from +1 to infinity. Okay, go practice. That's the only way to learn this stuff. Good luck.